Okay, in chapter exercise 4, first question, the locus of point P equidistant from these 2 points is this thing, then the value of C's. So by this point, we just need, we really need like a general formula for any perpendicular bisector, right? Let's just derive this. So question number 1. Yeah, so the slope from x1 y1 to x2 y2, that slope is just y2 minus y1 upon x2 minus x1, and negative 1 upon this slope. Well, that means negative of x2 minus x1 upon y2 minus y1. This thing, that is equal to the slope of this line. And what's this midpoint? Yeah, so this is going to be what? Y minus y1 plus y2 upon 2 upon x minus x1 plus x2 upon 2. It looks pretty horrible. That's all I can say about it. Let's do this thing. So y minus y1 plus y2 upon 2 times y2 minus y1 plus x minus x1 plus x2 upon 2 times x2 minus x1. This thing is equal to 0. So y2 minus y1 plus x2 minus x1 is equal to y2 squared minus y1 squared upon 2 plus x2 squared minus x1 squared upon 2, which is y2 squared plus x2 squared minus x1 squared plus y1 squared. All of that upon 2. Okay, cool. Oh, this should be y and x over there. Yes. Oh, in that case, C is pretty much just this value. Yeah. Oh, they put x1 minus x2, so it should be negative and all that stuff, but you get it, right? So the answer is basically, actually, you don't need all of this anymore. Right, delete this. You don't need this. So the answer will be x1 plus y1 x1 squared plus y1 squared minus x2 squared plus y2 squared, all of that upon 2. Yes, I think that's correct. Okay, next question. A variable line drawn through the points 1, 3 meets the x-axis at A and y-axis at B. Alright, cool. If the rectangle OAP, we can just draw this thing, question number 2. 1, 3 somewhere over there. So this is okay, through the points. Why points? It should just be a point. And you draw a line through it, and it meets the x-axis and y-axis at A and B. This is O probably. O is the origin. Rectangle OAPB is complete. Rectangle OAPB. And in that order, I think. So it's like this. The locus of P is, what kind of question even is this? So you know that these are like getting bisected, and this is just one line like that. So P is just twice of whatever this is. P is just 2, 6 like that, isn't it? Right? What else could it be? I mean, if you change this, for example, if you make it like this. Oh, okay. Now I understand what was going on. This is not the, this is not like that. It's not the midpoint of our diagonal. It's not that. So let's do this properly. So what is this? 1, 3? Some random line like this. Okay, and then it meets like this, and you want to find what the locus of P is. Cool. So say this is x, y, then this thing will be x and this thing will be y. Cool. Yeah, and what's this thing? This is just 1, 3. So if I talk about what this line is, right? Um, let's say that this, okay, this is not going to work really nicely because this is going to be what, x comma 0, this is going to be 0 comma y. Okay, try to do this. So y upon negative x, that's what this slope is. This is also equal to the slope of this line, which is 3 upon 1 minus x. Okay, and that means y minus yx equal to negative 3x. In other words, 3x plus y equal to xy. That is our locus. So it's like an hyperbola, I think. Okay, fine. Question number 3. Why is this a hyperbola of all things? Not sure why. Question number 3. If A and B are two fixed points and P moves such that angle APB equal to pi by 4, it will be an arc basically. So if you have A and B as two fixed points and you have this angle P, you have this P which is always moving, like, yeah, it will be an arc. It's pi by 4, right? So this will be, I mean, on the center of this arc, it will be pi by 2. Okay, so let's try to draw this circle. This is what the circle should look like. Right. And P is just any point on this circle. This angle will be pi by 4. Cool. Right, so this is the arc that we're talking about. Not this thing, because over here this angle is more than what we want. So it's just this much, not the full circle. Right. So do you want like a proof of this thing maybe? Who knows? Maybe they want a proof. So in that case, just say this thing is x1 comma, okay, yeah, x1 comma y1. Thing is x2 comma y2, and this guy is just x comma y. And then we will find out what these slopes are. Well, first this slope, then minus I mean the angle of the slope minus the angle of this slope. That's how it should be, I guess. So what is this slope? It's just y minus y2 upon x minus x2. Okay, that's m2, and then m1 is similarly just y minus y1 upon x minus x1. And what we want is this to be pi by 4. Tan of pi by 4 is 1. 1 equal to m2 minus m1 upon 1 plus m1 m2. Let's see if that turns out to be something nice. So this will be y minus y2 into x minus x1 minus y minus y1 into x minus x2 upon y minus y2. Oh, this should be different. It has to have heck. It has to have x over there. X minus x1 into x minus x2 plus y minus y1 into y minus y2. All right, this is getting very bad. But let's just see what degree is there. So this is xy. This thing has xy, but these will get cancelled. Everything else is just linear, right? All of the stuff over here is just linear terms at max. And this thing has x squared and y squared terms. So x squared plus y squared plus some other linear terms, which we don't care about. That will be the thing. Okay, cool. Yes, and next thing. Locus of P will be an arc, basically. Question number 4. B and C are fixed points having coordinates 3, 0 and negative 3, 0 respectively. This is question number 3. 3, 0 is B and negative 3, 0, that thing is C. It's the vertical angle BAC is 90 degree. Wait, what? Then the locus of the centroid of uh, vertical angle BAC. What does that mean? Vertical angle. I think you mean like this and not this. Maybe that's what they mean. Not sure what they're talking about. But angle BAC is 90 degree. That just means this thing is 90 degree like that. Locus of the centroid of triangle ABC. So A is a free point, and the locus of the centroid of triangle ABC is, I mean, it has what equation? So you know that A is just on this circle. Okay, draw it a little more correctly. You know these two are going to be diametrical points, so I will draw a circle about them, like so. And A will be any point on this, and then this will be 90 degree. Cool. This is the center, right? This is also the midpoint of B and C. So that means the median will be like this, and yeah, this will always be, I mean, this G guy, it will always be 1/3 of this distance. This distance is always 1/3 of this complete distance, but this distance is a constant. That means this distance is also a constant. That means this guy is actually on a circle as well. Cool. Right. And what kind of circle? Circle with 1/3 of radius with diametrical points -1, 0 and 1, 0 probably. Now we can do this. It's just 0, 0, and the radius is 1. So x squared plus y squared equal to 1. That's the thing, right? Yeah, I think so. So it's just the upper arc. So you can put y bigger than 0, right? These two combined give us the locus. I don't know what they mean by vertical angle, but I'm assuming they mean that this triangle must be upright and not downward. Who knows what that means? Question number 4. Oh, this was question number 4, and this was question number 3. So now we will go to question number 5. A variable rectangle PQRS has its side parallel to the fixed directions. Q and S lie respectively on the lines x equal to a, x equal to minus a, x equal to a, x equal to minus a. Q and S parallel to fixed directions. What fixed directions? Oh, so any fixed direction. Okay, I understand what they mean. Right. P lies on the x-axis. Locus of R is a line. Okay. Q and S lie respectively on these lines. So it's not necessary that this should be S. Maybe this could be S. Who knows? The thing is that P lies on the x-axis, maybe somewhere over here, and fixed directions could be anything. Say this and that. That could be your fixed directions. And is this a rectangle or a parallelogram? Rectangle. Cool. So like this. That's what these directions would be. So maybe this thing is Q, this thing is S, and then R would be like this, basically. Right. And as this P thing moves, you have different S and Q values. I mean Q points and stuff. So this guy also changes itself. I understand this, right? You don't know what these fixed directions really are. What do we know for sure? You know, these two add up to something. That means these two also add up to something because, yeah, well, they have to. No, wait. This is a different ratio. Oh no, this is not correct because these are like different ratios. These won't add up to something nice. Oh, then what do we do? This is 90 degree all the time. Oh, come on. It's just a bunch of rectangles in a box, basically, like this open container. It's a bunch of rectangles in those, and you want this vertex of that rectangle. What kind of path does it trace? There must be some solution that does not even apply coordinate geometry. There must be some kind of solution like that, but we don't know. We just don't know about that. Ah, okay, that's it. That's it. Let's do this actually. Instead of just waiting, let's do this thing. So this angle is constantly say theta, then this will be 90 minus theta. Say your P is, I don't know, at x value something, right? This thing is x, this thing is theta, and this will be a minus x, of course. So you know what this value is, you know what that value is. But you don't want that. You just want to find what this is. Oh, once you know what these points are, you know that the midpoints of these two are the same. So yeah, we can actually do that as well. Okay, cool. So what is this? What is Q really? It is a comma, what's the y coordinate? This thing is x, a minus x. So a minus x times tan theta, we'll just call this thing m. And this guy is minus a comma, well, its y coordinate is a plus x times 1 upon m, because this is cot theta. A comma minus a, sorry. This should be minus a comma a plus x upon m. That's what s is. Okay, and then the midpoint, call this thing x comma y. Now we already used x. Call this thing h comma k. So, and we know this thing is just x comma 0. So h plus x is equal to minus a plus a, which is 0. Oh, well, that is nice. H is always negative x. Okay, really nice. And k plus 0, okay, that is equal to this plus that, which is a upon m plus am, which is kind of a constant, and plus x into a upon m minus well, not a upon, it's just 1 upon m. 1 upon m minus m. There we go. And what is k? K is just the x coordinate, I mean it's a y coordinate of that. So for this guy I'm writing the equation y equal to a upon m plus am plus, it should be h and stuff over there. Okay, x is negative h, right? So this will be h, stop x, this is x, m minus 1 upon m. If you know what I did, you'd know. I'm not going to explain this. So yeah, it's a line. It's a line basically. So there we go. Fifth, we did it. Oh, what happened? Yes. Prove that 4 points whose coordinates in order are this form a square. Really. I'm going to cheat a bit. I'm going to move everything to the point 2 comma 1, and we'll see what that does. So moving everything to 2 comma 1, we just have, okay, this is question number 6, right? Moving everything to 2 comma 1, we just have negative 1 comma 3. Well, first of all 0 comma 0, then negative 1 comma 3, and then 3 comma, sorry, not 3, it's supposed to be 2, because 4 minus 2 is 2, 5 minus 1 is 4, and then 5 minus 2 is 3, and 2 minus 1 is 1. So are these 4 points forming a square? That's now what we're gonna ask. So if I try to graph this, it's just 0 comma 0. Negative 1 comma 3 is something like this. 2 comma 4, that is like so. What do they form a rectangle? Oh, that's weird. And 3 comma 1. Oh, so the rectangle should be like this in that case. Oh, a square. That's very different. So first of all, is this angle 90 degree? Mark this out. 3 comma 1, this is 2 comma 4, this is negative 1 comma 3, 0 comma 0. This slope is of course just 1 by 3. This slope is 3 upon negative 1, which is yeah, it's just negative 3. So yes, this angle is 90 degree for sure. And then for this guy, this slope is 3 upon minus 1, so it's negative 3, and this slope is 1 upon 3. Yes, so this is also 90 degree. Cool. Similarly, this slope 3 upon, oh well, already we got that this is 1/3 and this is minus 3, so yes, this will also be a 90 degree. So that's it. Now you prove this is 90 degree, this is also 90 degree in that case. So it's a rectangle at least. Now you just have to prove that these sides are equal. This side length is just square root of 9 plus 1, which is square root 10. This side length is just square root of 4 minus 1 is 3. 3 square is 9. This is 1 square. So it's also square root 10. There we go. It's a square. So no big deal. Question number 7. A variable straight line passes through a fixed point intersecting the coordinate axis at A and B. If O is the origin, then the locus of the centroid of same kind of question. Locus of the centroid of the triangle OAB. Well, you know that the midpoint traces out a hyperbola, so the centroid will also trace out a hyperbola because its distance is just its vector is 1/3 of the position vector of the midpoint. No, not 1/3, it's 2/3. Yeah. But still, let's try to do this. So we got, if this is your centroid x comma y, then what's this going to be, this midpoint? That's going to be 3 by 2x comma 3 by 2y, right? What is this length going to be? It's going to be 3x and this is going to be 3y. So 9 times x squared plus y squared, that thing is this length. What is this length really? Oh wait, it's not like that. Oh, it's a very different question. Sorry, this is not supposed to be happening like that. So no, it doesn't. Well, it does, right? I'm missing something. I'm mixing two different questions. Okay, let's just start from basics then. So fixed point A comma B, right? Yeah. Once again, you do the same thing. You just have A comma B is just somewhere in there. It's not even in the center. Just have some centroid x comma y, right? Then the midpoint will basically be 3 by 2x and 3 by 2y. Then this length will be 3x. So this point is like 3x comma 0 and this is 0 comma 3x. Sorry, 3y. Then what's the slope? The slope is just 3y upon negative 3x, which is negative y upon x. And this is equal to whatever this slope is, which is b upon e minus 3x. That means it's negative y positive 3xy. Oh, it's negative ay, sorry. Positive 3xy equal to bx. So a bx plus ay equal to 3xy. That is the thing, which is of course an hyperbola. Similarly, we got this midpoint is hyperbola, right? That's the question that I was talking about before I started doing the calculations. Okay, question number 8. Prove that if P is this point, Q is this point, R is this point, the three given points, then the locus of point as satisfying the relation, okay, is a straight line parallel to y-axis. SQ squared plus SR squared. Okay, equal to 2 times of SP squared. Huh. Let's graph this thing. Question number 8, right? So this thing is 0, uh, or origin. Then P is 1 comma 0, somewhere over there. Q is negative 1 comma 0. R is 2 comma 0, right? Huh. SQ squares is like some point. SQ, this thing is what? This thing is R and this thing is Q. SQ square equal to XQ square plus SR squared. Okay, this is weird. Plus SR squared is 2 times of SP squared. Okay. Well, that's weird. One thing that we can do is write it like this. It's like SQ squared minus SP squared plus SR squared minus SP squared equal to 0. And what that does, I mean, okay, this is plus all that stuff. What that does is now you just need to know what the x coordinate of this thing is, because the y coordinate is just irrelevant, right? So what is going to be I mean, how do I know it's going to be relevant? Okay. SP squared minus SP squared, that will be this thing squared minus this thing squared, because the height square will cancel out. So what is this thing? It has our coordinate x. Then this will be x plus 1, I believe. And similarly, okay, just write it in a better way, because we generally tend to think of x as a positive value, even though it can be positive, negative, whatever. So this is like this s, this guy, I mean, from 0 to this thing, that's x. All right, cool. So SQ, that thing is just x plus 1. So x plus 1 squared minus SP. SP is x minus 1. X minus 1 squared plus SR. SR is, okay, I know SQ is not x plus 1, it's this thing, but for that you will put only this much of length, which is x plus 1. So for SQ it's x plus 1. Similarly for SR, we have to put this length, which is 2 minus x, I think. Okay, minus SP once again. Cool. Actually, just write this thing is x minus 2. Who cares? And this will be, that will cancel out, and subtract 2, add 2x, subtract minus 1, add 2x minus 3 equal to 0. So 4x minus 2x plus 3 equal to 0. In other words, 2x equal to negative 3, or x equal to negative 3 by 2. That's the thing, x equal to negative 3 by 2. This is our final solution. Question number 9. Question number 9 is, if the acute angle between the diagonals of quadrilateral, the coordinates of whose vertices are in vertices in order are these. Okay, is theta. Angle between the diagonals. Okay, cool. Then tan theta is. So basically just find the slopes of the diagonals and then figure out the angle between them in that order, right? Quadrilateral whose vertices are in that order. So first diagonal is between 2 minus 1 and 2 3, which is basically just x equal to 2, I think. I mean, that's the line passing through them. Slope is infinity, if you will. So it's just x equal to 2. And the other line, I mean, the other diagonal, that will be 0 comma 2 and 4 comma 0. Okay, so for that, just have y minus 2 upon x equal to 2 upon minus 4, I think, because the response is it's minus 1 upon 2. In other words, 2y minus 4. What was I doing? Okay, 2y minus 4 equal to negative x. So x plus 2y equal to 4. That is the first diagonal, x equal to 2. That's the second diagonal. We don't even need all of this. We just need the slopes. We just need the slopes. Oh wait, x equal to 2. That's just a vertical line. So for this guy, your theta is 90 degree. For this guy, well, your slope was negative 1 by 2, right? That means your tan theta was negative 1 upon 2. That means theta was, well, we don't know what gives this as the thing, but we can definitely say it was just pi minus tan inverse of 1 by 2. Cool. So the acute angle between them, if I draw it like this, it's going to be tan inverse of 1 upon 2, like this. Yes, then this is just going to be a vertical line, right? This is the other diagonal. So the acute angle is just this guy. Yes, which is pi by 2 minus tan inverse of 1 upon 2. So what do you want? You just want tan theta. So this is our theta value, and tan theta will just be cot of tan inverse of 1. Wait, what? Yeah, cot of that. So we can write as 1 upon tan of tan inverse of 1 upon. Yes, I think that's correct. Which will be 2. So our answer is just 2. Why did I box this? I don't know. So 2 is the answer. Okay, next. Question number 10. A stick of length something rests against the floor and wall. I think I've seen this. If the stick begins to slide on the floor, the locus of its midpoint is a hyperbola. No, sorry, it's a circle. It's a circle. Yeah, right? Because 2x squared plus 2y squared equal to L squared. Oh, well, it's 10, right? So it's going to be 100, something like that. So just x squared plus y squared equal to 25. That is the thing. It's a circle. So is a circle like that. Question number 11. The locus of point which moves so that the sum of oh, we don't want this. Locus of point which moves so that the sum of the distances from the point c comma 0 and negative c comma 0 is 2a. Haven't we done this already? I don't know. It's just an ellipse. We know that for sure. So your AE value is just C. Your A value is A in this case. Nice. So E is just C upon A. Okay. What do you know? You know that B will be A square root of 1 minus E squared, which is A square root of 1 minus C squared upon A squared. Well, that will be square root of A squared minus C squared. Cool. So X squared upon, is this about the x-axis? Yes, it is. At least now it is. So it's going to be x squared upon a squared, which is, well, just a squared, can give us any value, plus y squared upon a squared minus c squared, because that's, yeah, that's b squared equal to 1. That is the equation. It's just an ellipse. Cool. If the vertex of a triangle ABC, vertices of a triangle ABC are these, prove that the bisector of angle C is parallel to y-axis. Okay. So question number 12. A is 2 comma negative 1. C is negative 1 comma negative 5. And B is negative 7 comma 3. You will find out what these slopes are first of all. So call this thing M1, this thing is M2. M1 is negative 5, negative of negative 1, which is negative 4, upon negative 1 minus 2, which is negative 3. So it's 4/3. M2 is 3 minus of minus 5, which is 8, upon minus 7 minus of minus 1, which is minus 6. That's going to be negative 4/3. Wait, what? Yeah, well, that is correct actually. Huh. Oh, yeah, I mean, of course. So these are just negatives of each other. So think about two lines with slopes that are just negatives. So like one makes an angle like this, one makes an angle like this. Oh, then actually this should be opposite. So 2 comma negative 1, that would be on the downside and this would be on the upside. Now it looks better. Cool. So now it's gonna be M2 over there, M1 over there, something. Right. So yeah, now you know how C actually is. What do you have to prove? Bisector of the angle is parallel to y-axis. It's not parallel to y-axis. Wait, how is this parallel to the y-axis? Oh yeah, of course. Negative 4. Okay, 4/3. It's bigger than 1, right? So this angle is actually bigger than 45 degrees. This angle is bigger than 45 degrees. This complete angle is bigger than 90 degrees. That's the problem. That's a problem because what that would mean is that this angle is smaller than 90 degrees. So this is actually the acute angle. Uh, so probably negative 1 negative 5. That's way down there. And in fact, this is how it should be. A is somewhere over there. I should have graphed this. So this angle is the one that we are bisecting. So yes, it's actually a vertical line. So that's nice. Question number 12 is just a proof question. Question number 11, sorry, question number 13. There we go. Okay, give a triangle ABC with coordinates of its vertices. Given a triangle ABC with coordinates of its vertices as these. If the angle between side AB and median drawn from the vertex A is theta. Wait, AB. So the median from C. Draw this. C, A, B. This is the median. Median drawn from the vertex A as well. Oh wait, no. No, this is not how it's supposed to be. Sorry. ABC beside AB and the median drawn from A. So these two lines. So the angle between these two is theta, then tan theta is. Okay. So first of all, you need to find what this line is. What's the midpoint of C and B? A is 6,8. B is 2,-4, and C is what? What is C? -6,4. So this midpoint will be -6 plus 2 is -4, -4. Half of that is -2, and this is just 0. So -2, 0 is the midpoint. You know what A is. You can figure out what the slope of this line is. So calling M1. M1 is 8/8. It's 1. What's M2 then? M2 is 12/4, which is 3. And this slope being 3, that's kind of weird. But that's how it is. Yeah, and this is obviously like an acute angle probably. I mean, it is an acute angle because that's how it should be, I think. Tan theta is. So no big deal. It's just tan theta equal to mod of M2 minus M1. It's 1. No, wait. It's 3 minus 1 upon 1 plus M1 M2, which is 4. So it's 2/5, I think. Okay, that was easy. Huh? Okay, 2/5. Next question. But still, just for surety, graph this thing. So 6,8 is somewhere like very far away. Then 2,-4 is like this, negative 6 comma 4. It's like that. A, B, C. Yes, it's an acute triangle, probably. Okay, so just move on. Question number 14. Point A and B are in the first quadrant. Point O is the origin. A and B are in the first quadrant. Okay, the slope of OA is 1. Slope of OB is 7. And OA equal to OB. Oh, that's really nice. Then the slope of AB is, so you can just find what A and B are, and then we'll be done basically, right? So this is just 1, right? And OA equal to OB. Let's just say these are on unit circles. This will be 1, this will be 1. Then this guy is just 1 upon square root 2, 1 upon square root 2, yes. And this slope is 7, right? So, oh, that's bad. 7. Okay, the slope is 1. Gotta do something about it. No easy Pythagorean triplet actually does this thing, so you have to go to the square roots and stuff. Fine. So this thing will be x, this will be 7x, then that means 50x squared equal to 1x is just 1 upon square root 50, which is 1 upon 5 square root 2, I think. That means these sides, they were just 1 upon 5 square root 2 and 7 upon 5 square root 2. So B is just 1 upon 5 square root 2, comma 7 upon 5 square root 2, and A is this guy. You know what? Just take this radius to be I don't know, 5 square root 2 instead. Yeah, that will be good. So take it to be 5 square root 2. You will just have B as 1 comma 7 and A as 5 comma 5. That's much better. So what's this slope? It's 7 minus 5, which is 2 upon 1 minus 5 is negative 4. It's negative 1 upon 2. That's it. Negative 1 upon 2 is the slope. Wait, did I say that? No. Why did it? Oh, it's supposed to be negative 4 over there. Then it's correct. Okay, question number 14 is done. Question number 15. Vertices of triangle A, B, C. Okay. Length of the angle bisector bisecting the internal angle B. Bisecting internal angle B. Okay, this is bad. So you will have to figure out the line and then figure out where does it intersect the side, I mean the opposite side, and then once you figured out both the points, you will have the distance. It's a lot of work, really. Can't we do something better to just get it done, basically? Huh. Oh, you can always figure out what the lengths are, right? What's the length AB? So question number 15. And then you can use the angle bisector theorem to get it done. Hopefully the lengths will be like good. If they aren't good, I mean the ratio, we want to take the ratio, right? So AB upon BC, that ratio is just square root of, for AB it's square root of 6 squared plus 8 squared, and for BC square root of 4 squared plus, oh, that is really nice because this thing is just 5, this thing is just 10, so it's 2. Oh, so A, B, C is like B, A, this is C, AB is 10, this thing is 5. You know what A and C are? You just know that the angle bisector will have 2:1 ratio like this using the angle bisector theorem. So you can figure out what this point is, and once you're done that, well, you got this thing. Cool. Yes, I think that is how it should be going. Okay, so what is this point? It is 1 times A plus 2 times C, which is 2 comma 8 upon 3. So 2 minus 1 is just 1. 8 plus 7 is 15. Wait, did I do like 30? It's negative 7, sorry. Yeah, that could have been a bad thing. So 1/3 once again. That's it. That's what this really is. So the length of angle bisector. So you know what B is. B is just 5 comma 1. There we go. We got it. Square root of 5 minus 1/3, which is 15 minus 1 is like 14. 14 by 3 squared plus 1 minus 1, that's just 2/3 squared, which is 2/3 square root of 7 squared plus 1. So it's 50 square root of 50. That's 10 square root of 2 upon 3, I think. That's what the value is. Okay, fine. Question number 16. The area of triangle ABC is constant and B and C are fixed in the shape of locus of A. Area is constant. Well, it's just a line. We just know this. Question number 16. Because if B and C are fixed, this base is fixed and this height must also be the same all the time. And that means it's just along this parallel. Can't ever go out of it. So it's a line. That's what it is. It's a line. Okay, next. Question number 17. Let A and B be given, okay, be 2 points and P move such that angle AB be equal to pi by 2 is, look, then the equation of P is, come on, seriously. So these are just diametrical ends, really. A and B are just diametrical ends. So it's x into x minus 2 plus y into, wait. This is not correct. It is x minus 2 into x minus 4 because both are just x coordinates, okay, plus y squared equal to 0. That is the locus. Yes. So x squared minus 6x plus what is this? Plus 8 plus y squared. Okay. Put y squared over here equal to 0. That's what it is. Okay, next question. In a triangle ABC, AB plus AC equal to 10. Question number 18. In triangle ABC, AB plus AC is 10 and coordinates of B. It's an ellipse. Yeah, it's just an ellipse with A equal to 5, AE equal to 3. Why? That means B is 4 because this triangle, right? AE, and B. Yeah. Actually, I should draw it like this. It's an ellipse like this. This is the center. This is AE. This thing is B. This thing is A. You know how it is. And if you don't, but go on, learn about ellipses. It's pretty fun. Yeah. What was I doing once again? Equation of locus A. So you got A and B values. Well, we're done basically. X squared upon 5 squared is 25. So y squared upon 16 equal to 1. Right? It's along the x axis, right? So that's it. This is the equation. Cool. Next. Oh, done. So 16x squared plus 20. Yeah, same stuff. Question number 17, x plus y squared plus 6. Yes. Question number 16, a line parallel to BC. I mean, yeah, you know what it is. Cool. Question number 13, it's 1 by 2. Your M1 is, yeah, just do it correctly. Question number what? Question number 13. Coordinates as these. Median drawn from vertex A is theta 0.9 theta. Okay. The median, that would be 2 minus 4, negative 6,4, 6,8. Yes, that's how it should be. So it really is just negative 2 comma 0. That's the midpoint. So that guy has the slope 8 upon 8. That's 1. And the other guy M2, that is having the slope 12 upon 4, which is 3. That is very, oh no, why is this 4 of all things? It should be 3. I mean 3 plus 1, that's not what I should have done. But yeah, it's basically 2 upon 4, that is 1 by 2. So this was wrong. Okay, my bad. Next, question number 12 is this guy. Wait, that's question number 11. Yeah, I mean, that is question number 12. It has no answer because it's a proof solution. It's a proof question, I think. Question number 10. Cool. Question number 9, 2. Yes. Where is it? Question number 8. Where is question number 8? Where is what is this thing? What's happening? They don't have question number 8 over there? Why? Question number 8 is, what is it? Oh, come on, question 8. Prove that if, okay, it's a straight line parallel to y-axis, and I found what that line is. It's a proof question, and that's why they don't have it. Question number 7. Yep, that's correct. Question number 4. Okay, 6 and 5 are proof questions, I think. Proof 4 is x plus 1 squared equal to 1. That is very correct. No condition on y, so not sure what the vertical angle means. But next, question number 3. Major arc of two circles cutting in B and A. Yes, that's exactly what I did. Then question number 2 is, I mean, okay, you could write this as 3 upon y plus 1 upon x equal to 1, but then fine. I like it like this better because it represents a hyperbola, and I like it like that. So question number 2 is correct. Question number 1, this thing, yes. Wait, did I just, why is this x2 squared minus x1 squared with it? Something's wrong. What went wrong? Well, I just flipped, right? So it should be x1 squared minus x2, but it's not like that. Well, this definitely is correct. This is also correct. And this is the correct slope as well, because y2 minus y1 upon x2 is x1. That is the actual slope. Negative 1 upon that. That's this thing. And then you move it over there and take it on the other side. This should work. Why is this y over there? It should be x. Yes, but it's the same thing. Okay. Not sure what they did, but I'm sure that this is actually the correct thing. So yeah, this is weird. I'm gonna give myself a correct. Right. So that's it. I'll see you guys in the next video.